Hello everybody, we are going to start part 3, lecture 7. So far we cover part 1 and part 2 of lecture 7. Now we are going to continue lecture 7. Before continuing lecture 7, I would like quickly recap what we already talked. In lecture 7 part 1 and part 2 we start to talk about the big data ecosystem, and in big data ecosystem we try to start with the introduction of big data, which we previously talked in previous video, talk about the big data models like 3V, 4V, 5Vs, something like that, and then we focus in part 1 and part 2 in big data ecosystem. In big data ecosystem, we mentioned there is a 3 main part. One is the big data storage system, one is the big data processing framework, one is the big data analyzing. We start and one more big data preliminary stage, which is focusing data ingestion and ETL process. This data ingestion and ETL process should be done before that 3 main section. So 3 main section was big data storage system, big data processing, big data analyzing. For big data storage, we started to talk about the big data storage, what is the difference between the big data storage and traditional one, what is the distributed computing. Then we dive into some tools like Hadoop and MapReduce, as well as focus to the Apache Spark. When we started Apache Spark, we talk a little bit about data abstraction in Spark. We talk several data abstraction in Spark, and we mentioned there is 3 main abstraction, which is RDD, data frames, and data sets. This is 3 main abstraction for Spark, and 2 supportive abstraction, which was DAG and Spark SQL. We discuss a lot about these 5 abstraction and talk about the comparison table of those abstractions. Then we started Spark workflow. Then we came to this slide, that Spark workflow including 12 sections. We already explained what's happening in the Spark. The reason we focus about the Spark because Spark is quite new and currently is the famous big data technology and tools which practically many company, many university use. So we came until here. Now, after finishing this section, we finish the main tools of the big data storage. One section remained for big data storage, that is next slide. So if I teach this section about the NoSQL, then big data storage will be finished. Then we will go inside big data processing and big data analyzing. And these 3 was a 3 main component of big data ecosystem. So this is very quick recap of the lecture 7 part 1 and part 2. Now we are going to start lecture 7 part 3, which is the last section of the lecture 7. So what is the NoSQL? So NoSQL is based on not SQL. No means not SQL. So traditional DBMS basically was based on the based on the SQL. So if many old DBMS like MySQL, PostgreSQL, and Oracle. When we are saying old, it means current one when we compare with the big data. In fact, many companies using the MySQL at the moment. but when we compare with a more advanced technology, we call it old. So mostly is based on the SQL, but big data is based on the no SQL, means not SQL. So because mainly the previous DBMS was basically structure the data. So more structural data use the SQL DB, but for not SQL DB or no SQL DB is used for all sort of data, structural data, semi-structured data, and unstructured data. So this is the what we call it no SQL. And DBMS means database management system, database DB management system. So what is the database? Database is a structured system to store, manage, and retrieve data. So this is traditional DB, which is based on the SQL and focus based on the pre-defined structure. So usually tables with the rows and columns like MySQL, PostgreSQL, Oracle. So traditional DB, when handling big data, will have many challenging, like what? Like scalability, flexibility, and performance. So scalability means hard to handle massive volume of data. Flexibility means it is not proper for semi-structured data or non-structured data. So that makes performance getting very low in the online and streaming data processing. So what is actually NoSQL? So NoSQL is not only SQL. So this is the word. So data can be in here any sort of data, as we mentioned, and that is handle large amount of the data. Opposite than traditional SQL data. So NoSQL data are schema-less, allowing flexibility. So the key advantages of NoSQL is scaling is horizontal and support for big data type, and this is good for online application. So this is very important. One of the big question, why not only SQL or NoSQL is important for big data? This is the question. Can you answer? Already we explained. You can use based on previous explanation. Because very scalable, very flexible, high performance, and distributed architecture. So this makes these four makes the main reason of the SQL and NoSQL DB. That makes when you are scalable, big data can manage and fit with many sort of type of data and handle NoSQL handle real-time data ingestion and processing efficiently. Especially data ingestion is good because as you remember, three parts of big data storage, processing, analyzing, they need ingestion and ETL, remember? So distributed architecture that you can divide your data, put several places, and without any problem of the failure. And so you don't need to keep your data in one places. So can you tell me, or can you guess how many sort of NoSQL data are available? So please think about this for a few seconds and pause the video and then tell me, can you guess how many sort of database are available? There is a four type of NoSQL database. One is the key value store. Data are simply like key and value. As you can see here, key and value is the one type of key value store. And another type is document database. So data is flexible semi-structured document, usually like JSON or BSON or XML. This is like XML, JSON file or BSON file. MongoDB is a store based on this format. This is for this one example is MongoDB. All useful for handling semi-structured data. For number one, we already mentioned. And another one is the column order database. So column order database store data in a column instead of rows, where columns are grouped into families. And the software like Cassandra, useful for real-time analytics and storing time series data. You see here, you have a name and occupation. Sometimes name and occupation come in one row, and another name and occupation another row. This is the row-oriented. Column-oriented, these together means both name come together, and then this another field rows come together. So this is the column-oriented DB, is one of the NoSQL DB. And another one, and the fourth one is graph database, store data as a node. So each node is an entity, and each edge, this is the edge, this edge relation between entity. A software name like Neo4j is using this method. This sort of NoSQL DB is good for analyzing complex network and connections like social media. So we already explained about the key value store is like Redis software. So it's based on the key and detail. So real world case like e-commerce platform to store the user session and shopping cart data. So this key value store advantages is the fast data retrieval. Document store, as I mentioned, flexible document, useful for handling semi-structured data like MongoDB. You can see XML-based, JSON-based format. And family-based, column family store is another third type of the NoSQL DB. Store as a column-based, like telecommunication to store and analyze the call records and log data. So this can be like this shape or this shape, as already explained. GraphDB, every entity and edge connection like social network to map user connection. So you can see comparison between the NoSQL and Spark ecosystem. In 1990, relational DB was famous, and then data warehousing come beside RDBMS, and then as you can see, NoSQL with the RDBMS together. Here, OLAP, meaning online analytical processing. So for the data warehousing, DW is a D and W, data warehousing. So OLAP is a technology used in data warehousing to perform complex query and analyze large amount of data. You know, OLAP enable multidimensional analyzing, such as looking at sales at different criteria, like for example sales by region or sales by product category or time period. This can handle, and this data warehouse store large amount of historical data from multiple stores and optimized for query and reporting. So you can see NoSQL 2 component, 3 component actually, key value and column store and DB from 2005. NoSQL for big data management was play very important roles beside Spark and NoSQL together managing very well. Hadoop play for storing and Spark for handling this DBMS play very great role for progress of RDMS. You can see here right use case for NoSQL for high volume data feed and for metadata. Metadata means data for data. When you have something which explain your data, for example, like product profile, product catalog, some information is some notebook or some extra document which explain your data, some extra document which can helpful for analyze data like data mining, or some sort of biometrics which is the additional information like fingerprint information as considered as a metadata, or content management like any content like news site, multi-device rendering. So when you have a big data and you need to keep it, no need cache statistic page. And good NoSQL good for sharing, store large object and simpler modeling of metadata. High volume data feeds, one of the use case of the NoSQL. This is the project name, like machine generated data, security data, social media project, advertising, targeting, real-time dashboard for showing report and other thing, and social media monitoring like game, any online survey happen. NoSQL play very important role for all of this. When we look at the NoSQL ecosystem, you can see that some sort of flexible data model of NoSQL is very good and make like dynamic schema, and data model is very flexible, sometimes for semi-structured data, sometimes by structured data. Even development is agile and data type is different, manage all sort of data type. Another NoSQL ecosystem is high data throughput, means practically system has the ability to handle a large volume of data, read and write. For read and write operation, not only read and write, but also efficiently. Operation would be efficiently. Throughput means operation. So high data and efficient, capability. Replica set to scale read means multiple copies of data are stored across the server, which allows scaling reads by distributing the workload. And sharing to scale writes, data is partitioned into the smaller chunks and distributed across multiple servers, allowing scaling write operation. So this is very important. So big data handling for NoSQL ecosystem, aggregate big amount of the data. Low latency. Latency actually is the time taken to retrieve or write data to the database. Low latency, of course, ensure quick response. Quick means millisecond, critical for real-time application. So feature in memory cache, frequently access data in store in memory, like Redis software, reducing time access comparing to the disk base, which we already talked, that Spark is the memory base, but the MapReduce is the disk base. Scale out working set, distributing data across the multiple server, ensure fast access and avoid bottleneck. So this is good for, especially low latency, good for financial trading platform. cloud computing everywhere. On the cloud, you can connect, no special hardware, so that is good. Commodity hardware, this refer to the affordable and widely available hardware. When we say commodity, means affordable and widely available hardware, like standard cable, Ethernet, local data storage. So this is designed to run on typical operating system and standard hardware configuration. So this is good. System like Hadoop and Cassandra leverages commodity hardware for distributed computing. So use case for this, a startup using the NoSQL database on regular server to build a scalable, cost-efficient system to manage that ecosystem. So we already finished until this step. What we finish first section of big data ecosystem. It was very important section. That was big data storage. So until here, big data storage finished. So remaining is the big data processing and big data analyzing, much easier than big data storage, which I'm going dive into those sections. So big data processing is a second part of the big data ecosystem. So in big data processing, framework designed to handle massive data set efficiently. We already talked about the processing. That processing enabled distributed and scalable fault tolerance data processing. We said there is a two: batch processing, real-time processing. Spark is very good for big data processing. For batch is like Hadoop and Hive and Pig, but for real-time processing, the Spark would be the best. And remember, Spark large data set for processing 100 times more than Hadoop MapReduce. Remember, because using the in-memory process. And I could show you, I prepared one table that would be good. So batch processing process large amount of data in a small piece within a specific time. But real time is real time. So data input is processed data in the chunk base. But in input for real time is continuous stream data. High latency for batch, but low latency for real-time processing. So use case usually use the batch processing for historical data, but real-time is for some security-based detection, live monitoring, something like that. Framework already explained. So the advantages, plus point of the batch processing, cost efficient for large data set. Very simple. Suitable for non-time sensitive application. When you have enough time, this is good. But real time, of course, is the real based, instant based. You can use it for online decision. Disadvantages: expensive, needs enough setup and updating, and may increase system resource usage because it's online. But this is the negative point of the real time. Negative point of the batch file is not suitable for real, of course, higher delay and inefficient for streaming data. So this is same as that table. You can pause and see more information, but I made all of this through the table. So parallel processing in the big data processing, very important point because your data is distributed, and then through the multiple process, then you want to do some process through the large data set. So this is very important. When we use, for a big data ecosystem, we use for big data processing this parallel processing. Spark, one of the software and framework which help us for parallel processing. And also this is parallel processing good for big data analyzing. So from the big data ecosystem, one is the big data processing, one is the big data analyzing, like EDA or predictive model, and ETL, which is preparation for big data ecosystem. So parallel, fast, parallel, very scalable. So if you see the parallel processing, computing method where a task is divided into a smaller, instruction executed concurrently on multiple processing unit or node. So this is the when we have a one program, then you have a separate CPU, then you try to get the result and then again bring to here. So this is reduced processing time because in the same time many CPU using your program. Flexible fault tolerance. So this is the good for yes, right here you see is a program CPU result, but in the sequential this is parallel, but usually in our computer usually is a sequential program. CPU do something, program sent to the CPU is like that. So reduce time, lower resource requirement, flexibility, fault tolerance. So in the there is another tools and options which let me explain. This is the scaling, a technique used for efficient management, store and process of data. So cloud provider like Amazon offer on-demand access to scalable computing. So you can scalable resources, reduce infrastructure cost. So there is a scaling type, sometimes vertical, sometimes horizontal. So like this vertical increase in the processing power, horizontal increase in number of machine. So scale up, when we say scale up means vertical scaling, when we say horizontal means adding multiple nodes to distributed workload. So usually a benefit for scaling, which is also parallel processing part of that, greater scalability, higher flexibility. So this horizontal has many advantages. Take capability for parallel calculation. Any task divided easily and executed independently. And complex and very complex task can be coordinated very well. So this is really suitable for horizontal processing, as already explained. Now let's talk a little bit about the big data analyzing. So big data analyzing can be in several parts. So when we talk about the big data analyzing, sometimes we are going to explore data. So sometimes is explore based. You want to explore. Sometimes you want to big data statistical analyzing. Sometimes you want to predictive modeling. And sometimes you are going to use visualizations, this sort of visualization, all big data visualization. So there is four big data exploratory data analyzing, usually called EDA. Another statistical big data analyze. Another is the predictive. Another big data visualization. Let's dive into. So we extract the insight and pattern, because big data storage, big data processing, big data analyzing. Big data analyzing in pyramid, remember in the DIKW, here is a data, big data storage here. Big data information and knowledge is big data processing. Big data analyzing is related here for extract the insight and patterns. So use many sort of algorithm, machine learning, AI, so can analyze historical data. So in many tools like Hive, like Drill, BI, like Power BI, also Spark. It is good. So as I mentioned, there is a 4 big data predictive model. So predictive is very clear, especially using some machine learning AI. A statistical test hypothesis is for statistical big data analyzing. Explorative means identify trend and correlation, find the anomalies, anything strange in data. And for visualization, you are using a good proper way for visualize. So little bit, let's explain more about each one in the coming slide. So EDA, exploratory data analyzing. So we try to do some sort of analyzing to summarize and visualizing data to identify some trend, correlation, anomalies. Tools Spark SQL, which was the best version of Spark, and other library like Pandas, Dask, and PySpark, which is useful for doing this process. And so any example use case like analyze customer behavior using the some transactional data. So step is you load the data set by Spark SQL or PySpark, perform basic visualization and identify anomaly. Anomaly means unusual data pattern. So big data analyzing from the EDA, really extracting actionable insight, massive data, it takes some time, some period. So data type usually using the EDA, including descriptive and predictive and prescriptive. We will talk more about this one in the data-driven decision making, which descriptive starting and predictive. Like if I show like here again, DIKW, here is the descriptive, means exploratory here. And here is the predictive, and one level is the diagnostic, and then predictive, and then doing prescriptive. So many techniques like machine learning, text analytics, graph analytics, real-time analytics. This is the example for that one. So regarding the big data analyzing, second statistical, you already know, but let's talk about the predictive modeling. So for predictive modeling, so usually is based on the machine learning, doing some AI-based large data analyzing. So machine learning automated complex analytical task and can predict and prescriptive analysis, like recommendation product. Tools like TensorFlow, scikit-learn, Spark MLlib, which next pages I will explain. So for Spark data frame and Spark MLlib, which is good for data analyzing for predicting. Column row structured data format, you remember NoSQL DB can use for machine learning analyzing. So this is simple. So Spark data frame, this is let's say this is the Spark data frame, and the Spark data frame apply for data transformation. Remember action and transformation. And so data processing for MLlib, which is a library of Spark. So this is the MLlib library support scalable machine learning. This is machine learning with a Spark. And so the process is the data acquisition, data cleaning. Then you need to train data, and using training from here, data divided test data and training data. Then you do one side for the test data, another is the training, and then model deployment. So this can be done for that purpose. So Spark is really good for data analyzing, especially for big data analyzing. So what the Spark do for doing the data processing and analyzing real time and stream processing. So in case of the we already talked about the batch and real-time processing, real-time immediately, but the chunk of data in a specific time base, and also the data streaming we already explained is the macro batches for efficient processing, support data stream for various resources. Application especially for fraud detection is good. And the last slide of the prediction big data analyzing is the specifically talk about the MLlib Spark, which is very great library in a large data processing, cover scalability, fit to the Spark ecosystem, is used for high-level API and provided high-level API for easier machine learning workflow. So benefit of MLlib is this distributed processing for fast training, integration for big data, and a unified workflow. So this is the common machine learning algorithm available, like classification regression, like linear regression, or generalized linear model, K-mean, and collaborating filtering. So this is the very powerful library for practical part, can play very important role. Okay, let's go for visualization. So big data visualization is very important, involve many graphical like charts, graph, dashboard showing pattern. Visualization is good to human readable, some specific like displaying real-time sales trend using the dashboard. So in the, for example, Spark UI is very good. Inside the Spark you can do, or another as open source like Superset or D3.js or Power. This is you need to pay Power BI for Microsoft. So visualization can manage like that. Let's few slides as a last section for big data security. Okay, before big data security, let's talk about the big data processing and big data analyzing. We started big data storage because processing and big data analyzing, it seems a similar process and analyzing. So please attention that big data processing is some sort of preparation step. But in big data analyzing, you extract final goal, some insight, wisdom. Big data processing is like preparation, and even because big data processing you prepare, some sort is similar data ingestion. And some people bring the data ingestion inside data. But here you should find some specific result. So big data analyzing like Spark, MLlib, but for big data processing like Spark itself. So often operational real-time batch, but here mostly real-time insight detection. This is mostly structure and clean, make the structure data, but this is one step after, extract the pattern. This is same as that table. I put more information. So you can see analyzing has is some sort of recap of our discussion, but in big data processing is two: batch processing, real-time processing, but this is for EDA and statistical machine learning, as well as this is the predictive model, right? Predictive model, but this is inside is a machine learning visualization, and you can pause the video. Already we talked about that one before. So for big data security and privacy, so this is very important. That's when you have a big data security challenges, you have a lot of data privacy issue, you need to use the security big data, like this is the Ranger is the famous. So handling big data issue, as well as governance and security, data quality, privacy, regulatory ethic in big data, and best practice for data government. Okay, let's go for some sort of application to see big data, some example for application, and some use cases. So retail and e-commerce for big data, healthcare and life science, finance and banking, manufacturing and IT, transportation and logistics. This is the many example like route optimization, predictive maintenance, or for healthcare, life science, personal medicine. This is prediction. So this is, if you see this sort of wide variety of data, only can handle through the big data. If we see some more use cases, let's check it out. So one is the Google page rank. This is treats web page as a node in a graph. Consider link between the page as a votes. Assign importance based on quantity and quality of inboard link. So this really changed the web search a lot. So this Google rank algorithm is very good, and many people follow and try to guess what the Google has for that one. This is one example. Another example is a Netflix, and Netflix recommendation system. So this is for user engagement is very important. So component including data collection, collaboration filtering, feature engineering, content-based filtering, and machine learning. So because in the Netflix a lot of users using, and that is very good using the big data, analyzing for here, save Netflix for $1 billion per year throughout increased retention. And real-time traffic management is very good. You can see, and for example, in a Seoul city, all taxi and buses, especially bus, managed by whole city through the municipality traffic center, which is called TOPIS. Real-time big data, whole buses managed. Or for another example is the financial fraud detection. This is another example. So can you tell what is the future trend for big data? Just pause the video. Yes, therefore future is an emerging technology like edge computing. Edge computing means you have a smartwatch in your hand. Here is a cloud. Instead of sending data to the cloud, you process on your smartwatch on top of your hand, analyze there. That's why they call edge computing. Or 5G means faster, is a network. Quantum computing, this has a potential for very complicated example. And advanced analytics like integration of AI and deep learning, real-time analytic advancement, and data governance and ethics we already talked. Okay, so already we finished lecture 7. Let's quickly recap some section we already talked. Okay, let's recap lecture 7. We discussed at the beginning about the characteristic of big data models. Recall many concepts like 3V, 9V. Little bit we again talk about the volume meaning, and we introduced some tools for each V. Then we started talk about the big data ecosystem. Before we talk about the big data ecosystem, we talk about data ingestion, means processing of the big data ecosystem, which we call it data ingestion, collection, prepare, and then storage, processing, analyzing. In this storage, we talk about some tools like Hadoop, MapReduce, and introduce the best one, which was Apache Spark, and explain a little bit very technically about the Spark in this section. And some application we talk through like Netflix recommendation or Google page rank base. And finally we come to some suggested for future trend and like edge computing, quantum computing, and so on. Let's give some key takeaways and future outlook. That role of data, and not only role of data, but also data is increasing dramatically. We need to worry about the quality and security and ethical issue, and we need to handling those data, integration with the AI. This is the future for current and for future. Data, big data would be complicated, privacy issue, new technology coming. So we need to think about that. And last page, as some call to action. So what you need to try to be advanced, especially in Apache Spark for processing, analyzing, and for Hadoop for storage. You should be update any information. Try to follow hands-on exercise, and you need to collaborating using this sort of techniques, various discipline, and try to, as I mentioned many times, ethical issue, because data, when giving many data, this is the big concern. Okay, thank you, student, and thank you for your attention. So we cover everything about the big data. Previously basic, but now very advanced and technical one. Very detailed. You cannot find such a lecture about the big data. Very simple, very complete, and very detailed, and very well connected concept together. So this lecture 7, wonderful. I hope you enjoy, and by many time watching this one, try to increase the big data, technical big data concept, and then already you have a AI, and then later on we will have one more lecture, combination of the big data and AI, which I call data-driven decision making, DDDK. So this makes you well prepared for such a concept everywhere. Thank you very much for everybody.